Dear students, welcome to today's chemistry session. And today's session, we are going to discuss polyhalogen compounds. In this polyhalogen compounds, we discuss methylene chloride and chloroform and carbon tetrachloride and CLC and DET. Now, first, we may take that what is poly? Poly means it is more than one, correct? It is more than one. If it is two, then it is dihalogen compounds, three trihalogen compounds, four tetrahalogen compounds. Okay. Then we are taking halogens. What is it halogen here? We are taking that the halogen that is X. And X may be fluorine or chlorine or bromine or iron. Correct? These are halogens. Okay. And halo means salt. Gen means produce. So here it is a halo. Halo means it is salt, and gen means produce. What is that? Producer. So salt produces the best salt ever. You know that is the table salt, sodium chloride. So salt producer are called as halogen, and poly means more than. And you know that we are taking the first hydrocarbon. What is the first hydrocarbon? That is methane, correct? It is CH4. It is methane. The first alkane, first number of alkane is methane. And methane are halogenation. For example, we are taking chlorination. We are taking chlorination. Methane is reacted with the chlorine. What will happen when it is reacted with chlorine? Now, we are getting that it is CH3 and Cl. So that it is monohalogen derivative. Monohalogen derivative. So that we are already know that it is alloalkane. Monohaloalkane. Now, further on, reacted with the chlorine. Further is reacted with the chlorine. What will happen? So listen, here it is reacted with the further chlorine. Then what is the byproduct here? By removal of HCl. So one of the hydrogen and one chlorine is removed. Then we are get methyl chloride, that is alloalkane. Now it is polyhalogen. What do you mean by polyhalogen? More than one halogen atom present in a carbon. Then it is known as polyhalogen. Polyhalogen. Okay. Now, further on chlorination, what will happen? Another one hydrogen from CH3 and the chlorine from Cl2 is removed as HCl. HCl. Then what will happen? Again, we are getting that this is CH2 and Cl. Correct? Now, two halogen atom is present. Then it is, what is the name? It is the derivative of methane. Derivative of methane. So that how many chlorine is there? That is two chlorine. So that it is dichloromethane. Dichloromethane. Called as methylene chloride. What is that? It is the name. What is that? It is dichloromethane. Dichloromethane or known as methylene chloride. What is that? Methylene chloride. Methylene chloride. So, it is dihalogen derivative. And further on chlorination, what will happen? So, further on chlorination. So, listen here, it is treated with the chlorine. Again, the same way, hydrogen from CH2 and the chlorine from Cl2 gas is removed. Then we remove that, that is HCl. We are removing our HCl. Then what is it? Then here we are getting that, that is CH, Cl3, CH, Cl3. And ever you know the name, it is nothing but trichloromethane because it is a derivative of methane. Now, what is the name? It is chloroform. What is that? Chloroform. So it is a trichloromethane, which is known as chloroform. Oh. Now, the final one, what is it? There is one more hydrogen is there, correct? Then further, it is reacted with chlorine gas again. So what is that? We are treating with the chlorine. Then we removal of HCl. So hydrogen, the final hydrogen is removed off. Then we are getting that. That is CCl4. Correct? That is carbon from methane, and all those hydrogen in methane is removed as chlorine, so that it is CCl4. Then it is a carbon tetrachloride. Carbon tetrachloride. So it is the name, it is carbon tetra. Tetra means 4. So it is carbon tetrachloride. Carbon tetrachloride. Now, in this session, we are taking that is dichloromethane or methylene chloride as a first compound. That is the first compound. Here we want to see. And second one, we are taking that is chloroform. So it is the second compound. Now we may take the preparation and the physical chemical properties of this chloroform. And the third component, it is carbon tetrachloride. So these are all the derivative of methane. We are already doing this monochloro derivative. Now we are taking these three components, that is dichloromethane and trichloromethane, and the tetrachloromethane is otherwise known as carbon tetrachloride. Correct? Okay. Now, so the first compound we are taking. Listen, what is the first compound? That is methylene chloride. What is that? Dihalogen. So first we are taking, that is dihalogen. Now, example of this, it is methylene chloride. What is that? Methylene chloride. Methylene chloride. Methylene chloride. Okay. What is the formula for methylene chloride? It is CH2 and Cl2. CH2, which is known as methylene, and the chloride, that is Cl2. The RLC is satisfied, so that we can't able to say that it is dichloride. If you are taking the IUPAC name, it is dichloromethane. So that it is the IUPAC name, It is dichloromethane. Dichloromethane is a IUPAC name of methylene chloride. Methylene chloride. Now, how do we prepare this methylene chloride? So that we attain the preparation method. Preparation of methylene chloride, that is CH2Cl. Okay, the first preparation method, okay, the first method, and it is direct halogenation. Direct halogenation. We are already done with this. What is it? Direct halogenation. What is direct halogenation? It is directly reacted with the chlorine. Well, we are taking that is methane. We are taking methane. Here, what is that? It is CH4, methane. Well, methane is reacted with chlorine. Methane is reacted with chlorine. That is Cl2 in presence of H in presence of HU. What is that here? HU. HU is nothing but photon. It is a photochemical reaction. Only in presence of sunlight, the reaction is fast. So it is the photochemical reaction. Photochemical reaction. Okay. So when methane is reacted with the chlorine, we get that is methyl chloride by removal of HCl. By removing hydrogen from methane and Cl from chlorine. So by removal of HCl, we are get that is CH3 bond Cl. One of the Cl is attached. Okay, then it follows free radical mechanics. It follows free radical mechanics. It is methyl chloride, but now I want to get methylene chloride. So further on halogenation. So what is further on halogenation? Further on halogenation, we are getting that is again Cl2 in presence of sunlight. Sunlight is represented as a photon, which is known as Hu. Okay, by removal of HCl here. So by removal of HCl, then we are get what is it? It is CH2 and Cl2. So CH2Cl2 methylene chloride is the product. Now stop the reaction here. So we may get it methylene chloride. Methylene chloride. That is dichloromethane. Now the second reaction. It is from chloroform. What is it? It is from chloroform. So that the second reaction we are taking, it is from chloroform. What is a chloroform? It is CHCl3. CHCl3 is nothing but chloroform. Correct? Now, how will you get chloroform to methylene chloride? What is that? Here CHCl3, which is converted into CH2Cl. So that here one hydrogen will be added, so that it is nothing but the reduction process. So we are getting that the reduction. What is that? Reduction. Reduction is nothing but addition of hydrogen. So that here it is the reduction process. So reduction of CHCl3. So we are taking a reduction process. We want to get a reducing agent which will produce the hydrogen. So that what is the reducing agent here? We are taking the reducing agent. Reducing agent. It is we are taking zinc and HCl. And zinc is treated with the HCl. What is the process? When zinc is treated with the HCl, then it will be formed zinc chloride and hydrogen, so that it will be produces hydrogen. Listen, we may take here what will happen here. Then zinc is reacted with HCl. Then what will happen? It will be formed zinc chloride, certain Cl. Under that, hydrogen gas is liberated. Correct? And this hydrogen is utilized for that reduction process, so that it is the reduction. And one more reducing agent we are taking, that is nickel and hydrogen. So that we are taking nickel and hydrogen. So that is nickel. In a nickel, hydrogen is present in the voids that the hydrogen is replaced for that reduction process. So here we are taking the chloroform on reduction by zinc, HCl and nickel hydrogen. We are get methylene chloride. Methylene chloride. Now listen, we are taking chloroform. We are taking chloroform now. So what is that? Here we are taking chloroform. What is that? That is CHCl3. When CHCl3 is reacted with, we are taking what is that? Zinc and HCl. What is zinc and HCl? It is a reducing agent which will be produces hydrogen. Which will produces hydrogen. That hydrogen is utilized for reduction. So that just here one of hydrogen is removed as HCl and one more hydrogen is added up. So we are getting that is CH2 and Cl2. So we are get CH2 and that Cl2. One of the hydrogen will be added here. We are get methylene chloride. And the same reaction is done by nickel and hydrogen is also. So we are taking nickel bar hydrogen, the hydrogen which is replaced for reduction process. So that we are getting methylene chloride. What is that? It is CH2 and that Cl2. So we make a methylene chloride. Methylene chloride. Okay. Now, what are the uses of this methylene chloride? Now we are taking the uses. So we are taking the uses of methylene chloride. Uses are CH2, Cl2, methylene chloride. And here the first uses. It is used as a solvent for metal cleaning. It is used as a solvent. It is used as a solvent for cleaning of metal. It is used as a solvent for cleaning of metals. Cleaning of metals. And second uses, it is used as a solvent for manufacturing of drugs. It is used as a solvent. It is used as a solvent for manufacturing of drugs. Manufacture of drugs. Manufacture of drugs. And it is used as a solvent for paint removal. It is used as a solvent for paint remover. Paint remover. And it is used as a aerosol propellant. Used as aerosol propellant. Aerosol propellant. Okay. So these are act as a aerosol propellants. And it is used as a solvent for de-waxing. So it is used for de-waxing. So these are the uses of methylene chloride. Okay. Now we may take the next compound. What is it? It is trihaloalkane. So we are taking, what is that? That is trihaloalkane. Trihaloalkane. Okay. Now, what is the example of trihaloalkane? So that we are taking the first one. It is CHCl3. What is that? It is trichloromethane. Trichloromethane. So that here it is otherwise known as chloroform. What is that? It is nothing but chloroform. Chloroform. And the name chloroform that will be done by Dumas. So that it is named by Dumas. Is named by Dumas. Why is named as Dumas? It contains chloro. It is chlorine. So chloro means chlorine. And the form that means here it is on hydrolysis. It will be produces formic acid. Why we call it is a form? That is, it is on hydrolysis. So it is on hydrolysis. Hydrolysis is nothing but treating with water and form that formic acid. What is that? Formic acids. So it is on hydrolysis. It will be formed formic acid, which is contains only one carbon. Formic acid, you know that. What is it? HCOOH. Formic acid. The acid which contains only one carbon. The first member of acid. That is formic acid. Okay. So here the form represents a formic acid and chloro represents the chlorine. So that it is called as chloroform. Chloroform. Okay. And the chloroform is a sweet smelling liquid. Sweet smelling liquid. You know that it may act as an anesthetic. Okay. Now we are using this anesthetic. What do you mean by anesthetic? Anesthetic, that means which will cause unconsciousness. And you hear the word chloroform is used as the anesthetic. Is it true? Definitely not. We may see later here. Okay. Now we may take another one. It is iodoform. What is that iodoform? Here it is the CHI3. CHI3. It is iodoform. What is that? Iodoform. Here also the same. What is that iodo? It contains iodine. And the form means which is on hydrolysis. We may get a formic acid. So that we may call this Now, what is the difference between this chloroform and the iodoform? Now, the chloroform is a liquid. It is the poisonous liquids. Yeah, take sweet smelling liquids. It is a liquid chloroform. But in the case of iodoform, it is a solid. It is a yellow crystalline solid. Yellow crystalline solid. So that it is yellow crystalline solid and it is a colorless liquid. Colorless liquids. Okay. Now, how will you get this chloroform and iodoform? And it is the reaction which is known as alloform reaction. If it is chlorine 3 times, then it is chloroform. Iodine 3 times in methane, then it is iodoform. And bromine is 3 times, then it is CH3R3, then it is known as bromopharm. Okay. Now, there is no fluoroform, it is not easily formed. So that your chloroform and the iodoform and the bromoform and most common chloroform and the iodoform. It is most stable. Okay. Now, preparation of chloroform, then it is known as alloform reaction. What is that? It is alloform. Alloform. Alloform reaction. Okay, listen. For the alloform reaction, we are taking that ethyl alcohol and bleaching powder as a reactant. So we are taking the reactants are for the alloform reaction. We are taking the reactants. So the reactants are ethyl alcohol. What is that? It is CH3, then CH2OH. What is that? It is ethyl alcohol and bleaching powder. You take one more compound. It is bleaching powder. So that it is ethyl alcohol, ethyl alcohol, and we are taking bleaching powder. You know the formula for bleaching powder? What is it? Here it is CaOCl2. It is nothing but bleaching powder. Bleaching powder. So, what are the reactants we are taking for alloform reaction? That is ethyl alcohol and the bleaching powder. Okay. Now, what will happen here? Why we are taking bleaching powder here? Here, this bleaching powder is a source of chlorine and calcium hydroxide. So, it will be gives chlorine and calcium hydroxide. So, for that purpose, we are using that bleaching powder. Now, what is the reaction actually takes place? Now, we are taking step 1. Here, we are taking the bleaching powder. Listen, we are taking a bleaching powder here. So, what is a bleaching powder? CaOCl2 bleaching powder. So that we are taking the bleaching powder here. The step 1 reaction we are taking. This is step 1 reaction. That is first step. Step 1. What will happen here? We are taking bleaching powder. What is bleaching powder? It is CaOCl2. Okay. Well, bleaching powder is reacted with what? It is nothing but on hydrolysis. So bleaching powder on hydrolysis, what will happen? We are getting that The first one, it is chlorine. Chlorine gas is liberated, chlorine, and remaining we get CaOH twice. So that we may get, that is calcium hydroxide. Calcium hydroxide. So we are getting chlorine and calcium hydroxide on hydrolysis of bleaching powder. On hydrolysis of bleaching powder. Then what will happen here? When this chlorine further on hydrolysis, we are getting a chlorine here, and this chlorine on further hydrolysis. Chlorine on further hydrolysis. Then what will happen here? That is 2 hydrogen and the chlorine is there. We are getting, that is 2 molecule of HCl. We are getting 2 molecule of HCl, and also that we are getting that the nascent oxygen. Correct? Here we are getting a nascent oxygen. Correct? And this oxygen is utilized to convert ethyl alcohol to acetal alcohol. Ethyl alcohol to acetal alcohol. Now we may take, that is a step 2. So what will happen here? That is a step 2. Oh, well, so bleaching powder and hydrolysis, we are getting the chlorine and calcium hydroxide, and chlorine further on hydrolysis, it will be produces nascent oxygen. It is step 1, it is on bleaching powder. Okay, now step 2, what will happen here when there is ethyl alcohol? We are taking ethyl alcohol, that is CH3, CH2, OH. When this ethyl alcohol is reacted with that, this nascent oxygen, it will be produced by chlorine water. So that we are getting, it is in presence of chlorine water. And chlorine water, they act as the oxidizing agent which will produce the nascent hydrogen. Okay, we already know that. That is reducing agent. What do you mean by reducing agent? A reducing agent is one which produces hydrogen. This hydrogen is utilized for the reaction. The same way here, chlorine water may act as an oxidizing agent, and they are reacted and produces the nascent oxygen. So this nascent oxygen is utilized for oxidation of alcohol. Now, what happened? Ethyl alcohol on oxidation. Ethyl alcohol on oxidation. It is a primary alcohol, and you know that primary alcohol on oxidation, it will be produces aldehyde. So here this hydrogen is removed, and we are getting the product, that is acetaldehyde. What is that? We are getting that, that is acetaldehyde. So that we are get, it is CH3, then CHO. So CH3, CHO, we are get, it is known as acetaldehyde. What is that? Acetaldehyde. So primary alcohol on oxidation, we may get aldehyde in presence of chlorine water. Now here what happen in chlorine water? When chlorine water may act as an oxidizing agent, it will be produces oxygen, and this oxygen is utilized for oxidation process. So we are get acetaldehyde as a product. What is that? Acetaldehyde as a product. Okay. Now, this acetaldehyde is further reacted with the chlorine. So we are taking the step 3. We are taking step 3. Here, this acetaldehyde is reacted with the chlorine. So we are taking acetaldehyde, that is CH3CHO. When acetaldehyde is reacted with chlorine, what will happen? When acetaldehyde is reacted with chlorine, on the alpha hydrogen is replaced by chlorine. What is alpha hydrogen? You know that. What is it? Next to functional. What is the functional group here? It is CH4. Correct? And here next to functional group, it is CH3. So that the hydrogen will be replaced by chlorine. So we may get it. What is the product? Here the C, and all the hydrogen will be replaced by chlorine. So that it is Cl3, and the remaining it is CHO. So it is trichloroacetaldehyde. Trichloroacetaldehyde. So we may want to balance here. So we are taking that 3 chlorine molecule. And so 3 chlorine molecule is reacted with this acetaldehyde molecule. Then we are get that is a trichloroacetaldehyde. So what is the name? It is trichloroacetaldehyde. Trichloroacetaldehyde, or otherwise known as it is chloride. What is that? Chloride, which is the component of DDT. One of the component of DDT. So that it is a chloride, and the CHO group is considered as A. Okay. Now it is trichloroacetaldehyde. Trichloroacetaldehyde. Okay. Now this trichloroacetaldehyde is reacted with calcium hydroxide, which is produced from the bleaching powder. So we are taking step 3. Step 3. Then we are getting the trichloroacetaldehyde or chloral, and this chloral or trichloroacetaldehyde, we are taking that is trichloroacetaldehyde, that is C, and Cl3, CCl3, and CHO, that is trichloroacetaldehyde. And this trichloroacetaldehyde is reacted with the calcium hydroxide, which is produced by bleaching powder. So that this is the calcium hydroxide and the chlorine, which is produced from that is bleaching powder. So that this trichloroacetaldehyde is reacted with is calcium hydroxide. It is reacted with calcium hydroxide. CaOH twice. Then what will happen? Now we may get that is chloroform. Then we are taking 2 molecules here, and what is the chloroform? Here we want to get that is CHCl3. That is chloroform. We may get chloroform, and remaining we may get a that is calcium formate. That is HCOO, and here it is Ca bond HCOO. So we may get calcium forming and the chloroform. So what is the name? It is chloroform. So chloroform is prepared by this way. So we may get chloroform. Okay, it is a chloroform. It is chloroform. So chloroform is prepared by taking ethyl alcohol and bleaching powder. Ethyl alcohol and the bleaching powder. And next, we may take the physical properties of chloroform. Is it? We may take the physical properties of chloroform. And we may take chloroform. Chloroform is a colorless liquid. You already know that it is a physical properties. physical properties. Chloroform is a colorless liquid. It is a colorless liquid and with sweet smell. It is a sweet smell. Considered as sickly smell, and it is a burning taste. It is burning taste. It is burning taste. And it may used as anesthetics or actors. It is not used as, it is act as anesthetics. It is act as anesthetic. And what do you mean by anesthetic? Okay. Anesthetic is one which affect CNS. Which affect CNS. What is that CNS? It is central nerve system. And will produce unconsciousness. So that anesthetic one which affects central nerve system and produces unconsciousness, so that it may act as an anesthetic. Okay. Now, I am asking previously one question. Chloroform nowadays is used as the anesthetic or not? Are you thinking about it? Then what is the answer? Is it chloroform is used as an anesthetic? Yes, definitely it will be act as an anesthetic. And it is used for the human beings. It is not used for the human beings. Why? Because it is an oxidation. It will be produces the poisonous gas that is positive. So we will take the chemical properties. Listen, here we are taking the chemical properties. Why it is not act as an anesthetics for human being? Okay. Now we may take a chloroform. We are taking the first reaction, that is chloroform, that is CHCl3. When chloroform on an oxidation, it is reacted with of molecules of oxygen. That is at oxidation. Okay. Then what will happen here? We may get the product that is positive. What is that? Here we may get COCl2. COCl2 by removal of HCl here. H and Cl is removed. So we may get by removal of HCl, we may get a COCl2. And this COCl2 is nothing but positive. What is that? It is positive. Okay. And the positive is a poisonous gas. It is a poisonous gas. You may get it is a poisonous gas. Poisonous gas. So what will happen here? Chloroform is utilized as an anesthetic. While we are inhaling oxygen, it will be produces oxygen. It will be produces oxygen as a poisonous gas. Then the patient get dead. So previously we are using the chloroform to done the operation, and the operation is success, but the patient died. Why? Then I analyzed recently the chloroform that will be produces a poisonous gas that is positive, and it will be the cause for death. So that chloroform is not utilized or used as a anesthetic for living things. Veterinary purpose for the beings. Now, what are the anesthetic nowadays? We are taking anesthetics nowadays. Anesthetic nowadays. So now we are using the anesthetic that is diazepam. What is that? Diazepam. And some ketamines and propofol. And ethers. So these are the anesthetic we are using now. But chloroform is not used as an anesthetic. Okay. Now, what happened when chloroform on reduction? We already know that the reduction of chloroform. The reduction of chloroform. So that the second one, that is reduction of chloroform. What happened when reduction of chloroform? We are getting that the methylene chloride. So that we are taking chloroform here. What is that? CHCl3. And it is reduced by zinc and that HCl as a reducing agent. Zinc and HCl. Or maybe it is reduced by that is nickel or hydrogen. Nickel bar hydrogen. Then we may get it. What is the product here? We may get a methylene chloride. So we are get that is CH2Cl2, and here also we will get the same thing, that is CH2Cl2. Methylene chloride is a product. Okay, and the next one, it is nitration. What is that? We are get the third reaction. It is nitration of chloroform. So that the third reaction, it is nitration. What is that? Nitration. When chloroform or nitration, yeah, think a chloroform. What is a chloroform? It is CHCl3. CHCl3. Chloroform on nitration. For nitration process, we are taking nitric acid. And for nitric acid, we are taking HOO NO2. HON2. Okay, it is nitric acid, HNO3, correct? And splitting into HONO. Now, for that reaction purpose, we are taking HONO. Now, what we taken here, there is HO from nitric acid, and that hydrogen from chloroform is removed. So we may remove that this hydrogen from chloroform and HO from nitric acid. Then we are getting that is CCl3 from chloroform, correct? It is CCl3 and NO2 from nitric acid. NO2 from nitric acid. So we may get CaCl3 and O2. So what is the name? It is chloropicrine. What is the name? It is chloropicrine. So we may get chloropicrine. Chloropicrine. Listen. Here it is a chloropicrine which is used as an insecticide. It is used as insecticide and also soil sterilizing agent. It is soil sterilizing agent. Soil sterilizing agent. So that the chloropicrine, which is used as an insecticide and soil sterilizing agent. Insecticide and soil sterilizing agent. Insecticide and soil sterilizing agent. Okay. Now, the next reaction, we are taking the next reaction. It is carbylamine reaction. Carbylamine reaction. So that the fourth reaction we are taking, it is carbylamine. Carbylamine reaction. And what is carbylamine? Carbylamine is nothing but the isocyanide reaction. And for that, we are taking that is primary amine. We are taking that and methylene. That is CH3 NH2. It is a primary amine, aliphatic primary amine. And this carbylamine reaction is used as a test for primary amine. So that it is only the primary amine answers the carbylamine test. Primary amine answers the carbylamine test. So that it is reacted with chloroform and primary amine is reacted with chloroform, that is CHCl3, and in presence of castic potash, that is KOH, potassium hydroxide. Potassium hydroxide. Then what will happen here? There is a 3Cl, so we are taking 3 KOH here. So 3Cl and 3K, that will be removed as potassium chloride. And there are 3 OH and that hydrogen here, NH2 2 hydrogen and CH 1 hydrogen. So that 3 hydrogen and 3 OH is removed as 1. So we may take the remaining. So what is the remaining? That is only CH3. CH3 is not affected, so that we are get that is CH3. And nitrogen in NH2 group is not affected, and that in chloroform we are adding that is C. So we are get CH3NC. CH3NC. Then it is methyl isocyanide. It is a chemical that is in the Bowman transit. So the Bowman transit, that is the gas which is leaked out. That is methyl isocyanide. Methyl isocyanide. And what are the byproducts here? We are get that is 3 molecule of KCl. We are getting 3 molecule of K and then Cl. So 3 molecule of KCl and the remaining we removed as 3 molecule of water. So 3 molecule of water. Then it is the chemical which is known as methyl. What is that? It is the methyl isocyanide. It is methyl isocyanide. And MC means isocyanide. Isocyanide is nothing but MC. And if you take the CN, then it is the cyanide. So CN means it is a cyanide. And the NC, that is isocyanide. So that here we are taking only that is isocyanide. So it is isocyanide we are getting. Methyl isocyanide, that is NC, we are getting. It is a chemical which starts the overall fast. Okay. And the next we are taking carbon tetrachloride. So that the third component we are taking carbon tetrachloride. So we are taking carbon tetrachloride. That is tetrahalogen. So the tetrahalogen, example of this, we are taking that is CCl4. What is that? Tetrachloromethane or carbon tetrachloride. So what is that? It is carbon tetrachloride, carbon tetrachloride or tetrachloromethane. How you put this carbon tetrachloride and tetrachloromethane? And here it is the simplest one. When methane is treated with the chlorine in presence of sunlight, the final product is carbon tetrachloride. Correct? They are already seen these reactions. So we are taking the carbon tetrachloride, the preparation of carbon tetrachloride. The first one we are taking methane. We are taking methane. And methane is reacted with chlorine. Methane is reacted with chlorine in presence of sunlight. That is actually new. Then we may get excess of chlorine. We are taking excess of chlorine. We are getting methyl chloride and methylene chloride and chloroform. And finally, we may get CCl4. We are get CCl4, that is carbon tetrachloride. Carbon tetrachloride and 4 molecule of HCl. 4 molecule of HCl. Okay, so the hydrogen from methane is removed as chlorine. So 4 and 4. So that we are taking that is 4 molecules of chlorine is utilized here. Okay, so carbon tetrachloride is prepared by this way. It is the first method of preparation. Okay, now we may take the second one. As second method, we may prepare carbon tetrachloride from carbon disulfide. When carbon disulfide is reacted with chlorine in presence of anhydrous AlCl3. Anhydrous AlCl3. Then we are getting that is CCl4. What is that? Here we are getting C and Cl4, carbon tetrachloride. Carbon tetrachloride. And then it is S2Cl2. And the byproducts are that is S2Cl2. By taking that is 3 moles of chlorine. So these two are the methods of preparing carbon tetrachloride. And the carbon tetrachloride is a colorless liquid and with a specific smell. So we are taking the properties. Properties of CCl4. And here we are taking the properties of ClCl4 and it may act as, that is a colorless liquid. It is a colorless liquid. It is a colorless liquid and it will be act as a fire extinguisher. It may act as fire extinguisher. So it will act as a fire extinguisher and it is insoluble in water and soluble in organic solids. So that it is insoluble in water and soluble in organic solids. Soluble in organic solid. So we are taking the three compounds. What are they? Methylene chloride and chloroform and carbon tetrachloride. And we are taking the next one, that is CFC. What is that? We are taking the next one. It is CFC. What is it? CFC. That is chlorofluoro derivatives of methane and that ethane. So we are taking the next one. It is CFC. Right? It is CFC. What is CFC? CFC is nothing but chlorofluoro derivative of methane and ethane. Then it is generally called as freons. You know that? It is freons. And you know that freon. What is freon? Freon is a gas which is used as a refrigerant in fridge and air conditioning. And it is the most pollutant to cause the deflection of ozone layer. Correct? Now, we may take that this CFC. And what is CFC? CFC is nothing but chloro. What is that? It is chloro fluoro so chlorofluoro derivative chlorofluoro derivative of methane and ethane. Only methane and ethane. So the chlorofluoro derivative of methane and ethane are called as CFC, which is known as P. Okay. Now, how will you name the CFC? There is a freon 1 and 2 and freon 1, freon 1, 3. Likewise, we may name it. Now, the UPSC nomenclature of freons. So, we will take the nomenclature of freon. So, we are taking the IUPAC names. IUPAC name of freon. So, the IUPAC name of freon. Listen, it is very, very simplest one. We are taking, for the freon, we are taking freon. Then it is C. It mentioned that is carbon and hydrogen and F fluid. So that freon CHF. That's it. What is it? C? C represents carbon. What is that? Here, carbon -1. Carbon -1. And H is nothing but, that is hydrogen. That is hydrogen +1 is number of hydrogen +1, number of carbon -1. And we are take F. F is nothing but, that is fluorine, number of fluorine. Number of fluorine. That's it. So we will name it the freons. Listen, we are naming some freon compounds. Listen. So how will you name it the freons? The first compound we are taking. Listen. The first compound, that is CF. Cl3. Cl3. Okay, how will you name it? First, we may take that number of carbon -1. So that we are taking number of carbon -1. So listen. So we are taking the first compound, that is the CFCl3. So how will you name it? The first one, it is C-1. And hydrogen +1. And that fluorine, we are taking, that is fluorine. And after that, we are taking the name. We are taking the name. Okay. Now, how many carbon? We are taking how many carbon? Only one carbon. So that is 1 - 1 become 0. And how many hydrogen here? There is no more hydrogen. So that is 0 + 1. So that it is 1. And how many fluorine? What is that? Only one fluorine. So that it is named as, it is the name. What is that? Here it is freon. And 0, 1, 1. So 0 is neglected. So that it is freon 1, 1. And the 1 represents number of hydrogen. There is no more hydrogen. So that we are taking number of hydrogen +1. And second one represents number of fluorine. Okay. Now we may take the second compound. What is it? It is CF2Cl. CF2Cl. Okay. Now CF2Cl, number of carbon, what is it? It is 1 carbon. So 1 - 1 is 0. Then number of hydrogen, there is no more hydrogen here also. So that it is 0 by adding 1 hydrogen. So that we are taking 1. And number of fluorine, it is 2. Correct. So that we may take number of hydrogen and number of carbon, and that is fluorine. So we may take that here, that is 2 fluorine. So we are taking that is freon. We are taking freon. It is 1, 2. Freon 1. So these two are the derivative of methane. Correct? And we may take the next one. Next compound, we are taking the third one. It is the C2, then F2, and Cl 4 times. Cl 4 times. Now, what is that? Here, number of carbon. How many number of carbon? That is 2 carbon. So that it is 2 - 1. It is nothing but 1. Okay. Number of hydrogen? there is no more hydrogen. So that 0 plus 1. So that it is 1. Number of fluorine. Number of fluorine, it is 2. So that we may take the name, it is freon. It is freon. And number of carbon is 1. So that it is 1. And number of hydrogen, there is no more hydrogen. So we wanted to add 1 hydrogen. So it is 1. And number of fluorine, it is 2. So that it is freon 1, 1, 2. Now you understand that? It is, what is freon 1, 1, 2? That is C2F2Cl. Okay. We may take one more example. Take the fourth example, that is C2F3Cl3. So what is that? It is C2F3Cl3. Okay. Now number of carbon, here also 2. So what is that? It is 2 minus 1. So that it is 1. And number of hydrogen, there is no more hydrogen here also. So that we are taking 0 plus 1. So that it is 1. And number of fluorine here. How many fluorine here? It is actually 3. So CF3, C2F3, CF3. So what is the name? It is freon. And it is 113. Correct? Freon 113. So these are the name of freon. So while we are naming the freon, we may take the count of, that is the carbon and the hydrogen under that fluid. So we may take the count, that is carbon minus 1 and the hydrogen plus 1, and the number of fluorine is acetate. So it is the name of the freon. Okay. And what is the use of freon? Freon is used as a refrigerant. So it is used as a refrigerant. It is used as a refrigerant in refrigerator and air conditioner. So we are taking the uses. So that it is act as a refrigerant. It is act as a refrigerant. In refrigerators, and AC air conditioners. And it is used as a propellant for aerosol. So it is used as a propellant in aerosols. Propellant in aerosols and deodorant and shaving paints. Deodorants and shaving creams. So these are the uses of freon. Okay, and which cause, that is ozone pigment. And we are take the next compound, that is DDT. What is that? We are take, that is DDT. So we are taking the final compound, that is DDT. And DDT, what is the name? That is DDT. That is diphenyl trichloroethane. So that is diphenyl chloroethane is nothing but DET. So dichloro, diphenyl, trichloroethane, which is known as DET. Then it is used as an insecticide and pesticides. So that we may take this DDT may used as insecticide and also may act as pesticide. Insecticide and the pesticide. Okay. And the insect lice, house flies, and the mosquito that will be killed by this DDT. And the insecticide which carries the diseases like malaria and the yellow fever, that insecticide is also killed by this DDT. And here we may take the pest, that is agricultural pest. So let's give that agricultural pest so that it is used as an insecticide as well as the pesticide. Okay. Now, how will you prepare this DDT? And it is prepared from, that is chloride, that is CCl3, CHO, trichloroacetaldehyde is known as chloride, and treated with the chlorobenzene. We may take it with chloral and chlorobenzene, we may get this DDT. So we may take the preparation of DDT. For that, we may take CCl3, CHO. What is that? It is chloride or trichloroacetaldehyde. So it is the name chloride. Chloride. But it is reacted with. Chlorobenzene. Reacted chlorobenzene. Here there is Cl and here there is H. And one more chlorobenzene we are taking. Here there is hydrogen and here there is chlorine in presence of sulfuric acid. In presence of sulfuric acid. And sulfuric acid is utilized for hydrolysis and also the dehydration. So what is the process here? We may remove the water molecule. We may remove the water molecule here. Then what is the product here? We are getting that. Listen, we are taking CCl3 as it is. So that this CCl3, CCl3 and CH. And one bond is connected with the benzene nucleus, that is chlorobenzene. Here it is C, chlorobenzene, and another one bond is connected with again chlorobenzene. Here it is C, and the Cl is present at that fourth position, correct? Here it is fourth position. It is 1 and 1. So 1, 4 position, which is known as para. So that it is para dash. Dichloro, diphenyl, trichloroethane. So that it is known as, that is DDT. So what is the name? It is para dash. Correct. Why it is para dash? One chlorine is attached to the fourth position. 1, 4 position is called as para. So para dash dichloro and it is diphenyl dichloro, diphenyl. Then it is 2 carbons, so that the parent hydrocarbon is ethane, and it is 3Cl, so that para dash dichloro, diphenyl, trichloro, ethane. This is ET. Okay. So listen, we have seen here we may conclude this session. We are taking methylene chloride. Okay. So in this polyhalogen compound, we are taking, that is methylene chloride, the first component, and the chloroform and the carbon tetrachloride. Now, how will you prepare this dihaloalkane methylene chloride? And methylene chloride is prepared from direct halogenation, correct? Direct halogenation of methane and reduction of chloroform. Okay, so reduction process we are utilized zinc and HCl. Zinc and HCl. Okay, and the second we are taking the uses of methylene chloride. What are the uses of methylene chloride? Most probably we are taking the solvent. So that the solvent for cleaning of metal and manufacture of drugs, and the solvent for paint removal. And also it is an aerosol and it is a de-waxing process. We are utilizing this methylene chloride. And the second compound we are taking trihaloalkane. What is trihaloalkane? Chloroform is taken as a trihaloalkane. How will you prepare the chloroform? Trihaloform reaction. And we may take the mechanism of this haloform reaction. Correct? For that, we are taking ethyl alcohol and the bleaching powder. What is bleaching powder? It is CaOCl2. CaOCl2 is a bleaching powder. Okay. Why we are taking the bleaching powder here? It will be a source of chlorine and the calcium hydroxide. So the chlorine as acts as the oxidizing agent and the calcium hydroxide as an alkali. So we are getting the chloroform. Now we are taking the physical properties of chloroform and the chemical properties of chloroform. It is a colorless, sweet-smelling liquid and burning taste. And chloroform may act as an anesthetic. It will be affected CNS, that is central nervous system, and produces unconsciousness. Okay, but it is not utilized for human being. Why? It will be produces the poisonous gas if it is on oxidation, then it is nothing but the positive. So, what are the anesthetic used nowadays? What are the diacetyl and the propofol and the ethers? These are the anesthetic which will produce us unconsciousness. It is a safest anesthetic nowadays. Okay, but if you are using a chloroform, it is unsafe. Then we are taking some reactions of chloroform, that is reduction of chloroform. We are already doing it. We use the methylene chloride and in nitration. It is we are treating with the nitric acid, we may get chloropicrine, which is an insecticide, and also it may act as uses soil sterilizing agent, which is chloropicrine. And carbon reaction. For carbon reaction, it is the test for primary effect. And carbon tetrachloride, the normal preparation method from methane and the carbon disulfide. And we are taking CFC, that is freon. There is status and naming of freon. Naming of freon under that is DDT preparation. DDT preparation. Okay. Okay. So let's
Thank you, sir.